I decided to do another live just to talk about something that has been on my mind this week. Hi, Lorena. Thanks for joining. Which is around what AI doesn't change about software engineering. Hi, Jake. Thanks for joining. And for kind of regular readers or followers of mine, the answer might not come as a massive surprise, which is around this concept of optionality. And really the key lesson or the key thing that optionality told me when I came across that concept in Kent Beck's writing, it was such a light bulb moment for me. And what it helped do was help me understand what I was doing as a software engineer. Like, whether I was hands-on code, whether I was managing teams, I was making architectural decisions, whether I was writing tests, coaching how to do TDD, all of these activities, obviously some of it's about writing code, some of it's about interpersonal relationships, all of this stuff. What was the thing that really it was about? What did it all ping together? And ultimately, the insight that optionality gave to me is that software is an economic exercise, is underpinned by economics. Anything we're doing has an economic purpose and an economic rationale. Hi, Kenan. Good to have you here. And so, and this in some ways, this is really obvious, right? Like, we are paid as software engineers to produce software. So of course there's like an economic incentive there, or an economic purpose. And generally the software we create makes money for the companies that that's the reason they pay us, right? So there's kind of an obvious economic lens to this. But what optionality really helped me understand is how this plays out on from everything from the decision at like a board level to invest in, a whole new team or something like that, all the way down to individual contributor decisions around, am I going to write this test? Is now the right time to refactor? How am I going to approach this new feature? All of these things are underpinned by the same economic reality, which I think optionality really describes. And I'm going to then explain how that same reality gets shifted by AI. It gets really redrawn in many ways, but it still remains the actual principles remain the same. And I think it's a really helpful way to then think about AI. So let's kind of taking the baseline, or let's leave AI for a second. What does optionality mean in the context of software engineering? How does these kind of economic principles make sense or play out on from everything from an individual contributor level all the way up to kind of entire organization of software creation? And the key thing here is what Kent Beck has now recently referred to as kind of features versus futures, which is a brilliant summation, which is essentially with software design and software engineering, we're operating in a trade-off space between $1 today and $10 tomorrow. So we know that we can create code, ship something fast, do that quick hack, figure out a sort of bodged way to do something, but it's really quick, right? It's not clean, it's not pretty, it's definitely not that repeatable or scalable or anything like that, but it gets something done. So this, we can think about the $1 today. We need it now. We're just going to do whatever we can to get it over the line as quickly as possible. And we'll hopefully come back and kind of fix it later. What does fixing actually mean? What does it mean to do it properly, do it the right way? And I do use these kind of bunny quotes, these quotation marks a lot, because there can be this like moral imperative that can come into these kind of analysis of there is a right way and a wrong way to do software. There is a right way. This is clean architecture, implying that over here is like dirty and bad, right? Like this is this is the right way to do it, the proper way. And I think for me, what is really interesting about the optionality frame is that it kind of removes this moral element to it. So yes, we have a way of doing it quick and dirty, right? So I'm using that kind of judgmental language again, but we have a way of doing it quickly. Let's just say quickly, right? But potentially it's not going to be that easy to change in the future. So this is the key insight that optionality gives us, is that when software is easier to change, it is more valuable. So the easier it is to change, the more valuable it is. And so it's worth $10 tomorrow. So we have this trade-off between $1 today and $10 tomorrow. And the two examples I kind of give of this to help illustrate it are, on the one hand, we have the idea of two apps, right? Two apps that are identical in every single way. They have the exact same functionality. They look identical. You could not tell the difference just by looking at them, that there's any difference between them at all. And one could be worth 10 times more than the other. And how does that make sense? Why would that be the case? Because app B, the one that's worth 10 times more, when you look at it, is, it has all those good things. It's got tests, it's cleanly architected, it's got strong CI/CD deployment pipelines, all of this stuff that, makes it, which we consider good, that makes it easy to change. That makes it valuable, because when there's a new feature request, when a new competitor enters the market, any of these things occurs, it can adapt, it can change. We know we can add a new feature, we can add a new drop down here, we can tweak the colors, we can change the UI simply because it's all in the design system, whatever it is. All these things that we consider good really equate to easy to change. And on the other hand, we have the app which is complete spaghetti code, no tests, manual deployment pipeline, which the engineer who knows how to do it has just gone on holiday. All of these things, a complete nightmare to deal with, a complete nightmare to change. That's what makes it less valuable. So we have this idea of, actually, this isn't about good engineering practices and not about like the right way of doing it. It's simply more valuable. It literally creates more value. How does it create more value? So the example I like to think of is like a flexi ticket. So when you're going to an airport, or you're going to get a train, you can buy a flexible ticket, usually for more money than a kind of single ticket would be. So I have to be on that flight at that exact time, and if I miss it, that's it. I'll have to buy a whole new ticket, or I have this flexi ticket and I can get on a later flight, for example, if I miss that one, or a slightly earlier one, or whichever way around. Now, you might be very happy to pay 10, 20% more for that flexible ticket, right? Because it gives you that flexibility. Would you pay, 50% more? Would you pay 70% more, 80% more? Then it starts getting, maybe you go, well, it's not worth it. I'll just make sure I turn up on time. But if you knew on that day, the friend you're traveling with is notoriously flaky, the trains are on strike, the Uber, the Uber's, this Uber system is being hacked and is down, or something like that. If all these things suddenly make it very difficult or more challenging, or more importantly, raise the uncertainty of getting to the airport, you'd be willing to pay more for that flexible ticket to have that security. And so this is the key idea, is the ability to change combined with the level of uncertainty. That is the key driver of value. The easier software is to change, and the more uncertain the condition it's operating in, the more valuable that software is. And so, if having easy to change software that never needs to change, that that never needs to change, because it's a bit of old banking software that's going to run for 30 years, and it just that regulation isn't going to change for 40, for a very long time. The need or the economic value of refactoring it all and making it really easy to change is diminished, because actually it does what it needs to do. We never really need to change it. We don't have to look at it again. I'm sure you've all dealt with certain systems in in a company where you might look at it and go, God, that's a bit of a mess. But actually, it never gets around to being addressed, partly because it just never changes enough. It doesn't cause enough friction to be worth going in and like making it better. And so we've talked about optionality. We've talked about this idea of why software that's easier to change, especially in the face of uncertainty, is more valuable. So what does that all mean in terms of AI, and what does AI not change about software? So the key, I don't think software changes this core economic insight, and obviously optionality is not a uniquely it comes from the financial world, right? It's not a unique term that Kent Beck invented for software. It's borrowed from sort of wider financial theory. And so in with AI, well, what do we have? Well, we now have the ability to change software or to create software far more cheaply than ever before. So in that and the time, the ability to create that software is massively reduced. So for both in terms of speed and cost, we can create software at just a stupendously different rate to anything we've had previously. And I know we're already seeing this. This will lead to an explosion in the amount of software that is being created. Once you remove the hard limit of someone, a professional developer, with X years of experience to and the amount of money it take to hire them to build up your app idea. Most app ideas, how many, if any of you worked in software, how many times when people come out to go, I've got this great app idea. I've always wanted to do this. And you go, okay, well, actually, when you think about how much it would cost to get that off the ground in the pre-AI world, it will never happen. So, um, you know, but now people can have that app idea and they can speak it into Bolt or Lovable or Replit, and they can have something that works sometimes, kind of. But those tools will get better and better. I'm not actually knocking them. That's incredible, right? That really hugely opens the field. I do think it'll be a case of kind of Jevons paradox, is this idea of as the cost comes down, the demand will massively expand. So more and more people will create their own little apps, their own bits of custom software for themselves, their small communities, the stuff that would never be funded or ever make sense as like a venture scale or even like a quote unquote proper business could absolutely now be created and validated and maybe would never need to become a business. It's just for that personal usage. But what you will have is people creating software now, delivering this dollar today, right? So now I can deliver a dollar today potentially for pennies. I can ship it an early version and just get user feedback, right? Is anyone interested in this sort of thing? And if actually it turns out that people are interested, and there was in a recent article I wrote for Lead Dev, I interviewed some folks working in the space, and Rob, the owner of the Old Street agency in London, he was talking about how he literally had a client who had come to him saying he vibe coded an app which had like 6 paying customers. So he actually had people paying for his app, but now he was too afraid to touch it, right? He now needed a professional development team to come in and help support it because he didn't really understand what was going on under the hood. And this is the key thing. He was afraid to change it. He couldn't go in and change it because he didn't understand it, and the LLM too easily could tweak or change something that would then break the whole app, and he wouldn't know how to fix it. So we had this classic example, an amazing example of a dollar delivered today, right? So he actually had validated that there were people would pay money for this product without having to hire any professional developers. And think about the corollary of this, the flip side of this, which is probably one of the hardest things in software in my experience is, let's say this person had spent, saved up a bunch of money, taken out a loan, whatever it is, and invested that in getting developers to build out a product. But then imagine no one signed up, no one was willing to pay for it. It's a huge loss, but also as the people building it, they've built some software, and actually it turns out people didn't need it, they didn't want it. That sucks. That's that's as annoying as it is when that small little feature you ship, which you just kind of rushed out, and it was a bit of a kind of side thought, turned out to be this critical piece of infrastructure that, massively, suddenly this small little feature that was meant to be doing something else is now, everyone using your app is suddenly using this in a way unexpectedly, and it's now become a critical part of the product. That has its own headaches and challenges, but in a way they're good problems. It's definitely much better than the alternative. When you put your heart and soul into building and money into building something out that you believe in, and it turns out, actually no one wants it or wasn't solving the right case. So I think AI should really solve that. Like, we should only be getting engineers to look at something that is genuinely needed and genuinely economically valuable. And in this case, this person has proved out enough to themselves that there is a market there and it's worth now investing in, which is brilliant. And I think we'll see way more of this, but it doesn't replace the developer, because as I said, it gets to a point where it needs to be able to change, and an LLM hits a limit. Now, there is obviously this idea about the bitter lesson that actually, you know, if we augment, the kind of lesson from ML, machine learning kind of research and AI research over the last decade or so, that if we try and supplement these systems with human kind of workarounds and intelligences, that actually the bitter lesson is that generally you just keep scaling, compute, you keep scaling the stuff, and AI will just blast through it. You don't need kind of humans doing some specific workarounds to help them overcome a block. If you keep scaling, kind of the AI will just find a way. And what does that mean in the context of kind of optionality and what software engineers do? There is absolutely a case where, I still believe as of today, it's clear to me that LLMs are fantastic at delivering a dollar today, at being able to create and running autonomously, independently for longer and longer periods, being able to, I saw that, I think, using uh, the OpenAI ChatGPT 5.2 model, someone's able to create a browser, an entire web browser with 3 million lines of code, leaving an agent to run uninterrupted for like 24 hours or something. And that is mind boggling, right? However, so this kind of comes back to this something that is a very interesting kind of tension that's coming out at the moment between, I've got the exact thing I want to build in mind, and I want to go off and build it and invest a bunch of money into an AI agent to run for 24 hours to go and build it and build 3 million lines of code, versus I'm going to ship iteratively, deliver something, get feedback, keep and kind of, get consistent feedback. I think that's probably a topic for a different day. But the key idea here is, even if we go, okay, we're going to have agents going out and, writing web browsers, there is still, first of all, there's still an economic trade-off there, right? I'm, absolutely, it will be cheaper to get an agent to go off and build that web browser than a human. But there's still going to be economic decisions. Are there strategies I could do where I'm going to send an agent to maybe explore a few different approaches, and then I want it to move to, invest in, once it's validated some approaches, I want to then invest, a more expensive model to then go in and, build that out more properly. So even if we're in a world where it's all agent orchestration, which could well be the world we're moving into, this economic underpinning still makes sense. You're still in the exact same trade-off space of $1 today versus $1 tomorrow. The speed and the scales that we're dealing with are going to be, far faster and, far more compressed than ever before. It's no longer just a CTO and a C-level board looking at how many engineers they have and what they're willing to invest. These are decisions now that are going to be happening on an individual contributor basis. Where do I allocate my resources? What am I optimizing for? And I think that this comes way back to, regardless of, AI or not, this trade-off space between dollar today and $10 tomorrow is something that is at the core of software engineering. And it's something that I think a lot of software engineers, certainly myself, or at least I can only speak for myself, that I wasn't aware I was making these trade-offs. I intuitively knew it, I was kind of naturally doing it. But certainly one of the pitfalls I fell into quite often was, I thought that, my job was to focus on the optionality, was to focus on the $10 tomorrow, because no one else could. And that is true. You're never going to have a CEO or a non-technical person barging in saying, hey, when are you going to refactor that component? When are we going to, make sure that solid principles are being applied in this code base, or whatever it is, right? Only the technically minded folk, the engineers, the developers, are going to be able to see that view, right, and make those decisions. But the trap, therefore, I fell into was going, well, that's my job and that's all I do. And so now I'm in a battle, right? I'm in a battle with the product manager or the founder or whoever it is, saying, hey, we need this quickly. We need this like tomorrow. We need this yesterday because we've got a demo, or we've got, this new Q1 initiative coming up and it needs to be done before then. Whatever it is, you've got the pressure of the dollar today. And it became often quite like a battle, right? It was like, there's this side over here saying, hey, we need to ship it now. Over here going, oh, we need to do this right. And then it's this And actually, there's this tug of war, this tension, and actually, it's not a battle. We're all playing on the same team. We're trying to achieve the same thing, which is we want to create software that's valuable and, you know, delivers enough economic returns to pay our salaries, to keep the company going, to increase the equity of the value of our stock, whatever it is, however, whatever the incentive is. But really, we want to create more value. But it is a trade-off, right? And we can't truly accurately make that trade-off unless we understand the pressures on the dollar today, right? It's a constantly shifting tension, and it's a kind of, in the middle of this Venn diagram, this sweet spot, which is always going to be moving. It's that dynamic space. That's where real value is created, because if we make a mistake on either side, whether we're shipping and like leaving future value on the table because we're not considering how to make this easy to change and we don't care, then we're losing out the $10 today. And similarly, if we're only focusing on $10 today and end up dying, or because we build this beautiful system, but actually turns out no one needs it, or it's not solving the real problem, whatever that might be, then that's also worthless, right? So we have to find the balance. And AI doesn't change this. AI is the exact same. It's the exact same trade-off. We might be making it with different tools. We might be making it at different scales that we used to. But the underlying principle, the underlying economic trade-off space that we navigate as software engineers, as developers, does not change with AI. And in fact, it crystallizes it. It makes it clearer than ever before that this is what we do. This is what our purpose is, what our value is. And it's not always comfortable. It might mean we have to understand the business context we operate in. It might force us way closer to things like selling, to things like design, to things like operations than we've ever been needed to before, to really understand the space in which we're operating in. The flip side is, and the benefit is, I think we're seeing much greater appreciation of what it is engineers actually do. Now that anyone can come in and create an app and get something working, they're increasingly understanding that it's not the coding, it's not the, getting a new web page up and running that the developer does. It's they make it easier to change. They make it valuable by making it reliable, by making it scalable, by making it simply, easy to adapt and easy to adapt. And especially in a time of great uncertainty, which we're in, that becomes ever more valuable. So that is where I'm going to leave it for today. Thank you, everyone who joined the call and listened in. And for those watching back, appreciate your time. If you have any comments or questions, always happy to hear them. If you're subscribing to this or not subscribing to it, please do. Either I will post this on YouTube as well. Follow me along on Engineering Harmony. And that's it for now. Have a great weekend, everyone. Thanks.